All right, let's get right into it. We have these large language models that are, incredibly powerful, but they've got a big problem. Today, we're going to break down the two main ways people are trying to solve it. Retrieval augmented generation, you'll hear it called RAG, and the classic, fine tuning.
So here's the central issue, right? An LLM's knowledge is basically stuck in the past. It's a snapshot from whenever it was trained. So if you ask it about something that just happened or about your company's latest internal report, it has no clue. So the question is, how do we bring it up to speed? Some researchers at Microsoft came up with this perfect analogy that really nails the choice we have to make. Think about a student who has a big test coming up. What's their strategy? Do they spend all night cramming, trying to memorize every single fact? That's fine tuning. Or do they just bring the textbook to the exam and look up the answers as they go? That's RAG. It's the exact same dilemma we face with these AIs.
Okay, so here's our roadmap. We're going to start by digging into the AI's knowledge problem itself. Then we'll explore fine tuning, then RAG. After that, we'll see them go head to head, uncover a really surprising twist in the data, and then we'll wrap it all up with how you can pick the right strategy for your own needs.
First things first, the AI's knowledge problem. I mean, these models feel like they know everything, but that knowledge is far from perfect. It's got some really specific and pretty critical limitations that cause those factual errors we sometimes call hallucinations. And the research actually gives us a great way to think about these mistakes. Sometimes it's just a domain deficit. The model simply wasn't trained on, say, advanced particle physics. Easy enough. Other times, the info's just plain old. But the really interesting reasons are a bit trickier. You've got immemorization, which is when the model saw a rare fact during training, but it just didn't stick. Like hearing someone's name at a party and it's gone 2 seconds later. Then there's the really wild one, catastrophic forgetting. This happens when you try to teach the model something new, and in the process, it just overwrites and forgets something it already knew. It's wild. And finally, sometimes it has all the right puzzle pieces, but just can't put them together logically. Okay, so let's check out our first solution, fine tuning. This is our student who's studying before the test. The whole idea here is to permanently bake new information right into the AI's brain before you even ask it a single question. So the textbook definition calls it a process of adapting a pre-trained model. But what does that really mean? Well, you take a giant general-purpose model like a GPT-4, and you keep training it, but on a much smaller, super specific set of data. This actually rewires the model's internals to make it an expert in that one narrow thing. And this is the most important part to understand about fine-tuning. The new info isn't just a cheat sheet. It becomes a fundamental part of the model. The knowledge gets baked right into the millions, sometimes billions, of tiny little parameters or weights inside the neural network itself. Now, let's talk about our other student, the one who's a huge fan of the open book exam. This is retrieval augmented generation, or RAG. This approach doesn't even try to make the model memorize new stuff. Instead, it just gives the AI a library card to an external database it can check out in real time. With RAG, the core model, it stays exactly the same. Its internal brain wiring is frozen. All the magic happens by cleverly beefing up your prompt. Before the model even sees your question, the RAG system zips out, finds relevant documents from a knowledge base, and then crams all that info into the prompt. It gives the model all the context it needs to sound like an expert. It sounds complicated, but let's walk through it. It's really just a 4-step dance. 1, you ask a question. 2, a retriever system instantly searches a database for stuff that's relevant to your query. 3, it grabs the best bits of text it finds and literally pastes them into your original prompt. And 4, this new supercharged prompt gets sent to the LLM, which now has all this rich context to work with to give you a super precise, fact-based answer. Okay, so we've met our two contenders, the crammer and the librarian. Now it's time for the showdown. Let's see how they actually stack up when it comes to the things that really matter for a project. At a high level, the trade-offs are pretty stark. RAG uses external knowledge, which is way cheaper to get going and, crucially, can be updated in real time. You just add a new document to the database and boom, the AI knows it. Fine-tuning, on the other hand, internalizes knowledge, and that is an expensive and slow training process. The model's knowledge is completely static until you decide to go through that whole painful retraining process all over again. Now, let's zoom in and see how this actually plays out for a business. When it comes to governance and security, RIG is the clear winner. Your data stays put, right where it is, secure and auditable. With fine-tuning, that data gets swallowed up by the model, and it becomes a total black box. But look at latency. Fine-tuning is a speed demon. It gives you answers in under a second, while that retrieval step in RAG adds a noticeable 1 to 3 second delay.
Okay, so this all leads to the million-dollar question, doesn't it? We've talked about cost, we've talked about complexity and speed. But when it comes to the whole point of this, injecting new knowledge to get more accurate answers, which one actually does a better job? Well, the results from a direct comparison are pretty mind-blowing, actually. Researchers measured the accuracy gain for each approach. And as you can see, fine-tuning on its own, that's the first bar, gave the smallest boost. Combining them was a little better. But look at that third bar. The single biggest jump in accuracy came from just using RAG with the original off-the-shelf model.
So, the verdict is in, and it's pretty unambiguous. For the specific job of teaching an LLM new facts so it can answer questions better, RAG is the clear champion. It's just more effective, it's more reliable, and it consistently gets better results than this kind of fine-tuning.
But hold on, because the story doesn't quite end there. The same research that basically crowned RAG the winner also found this really fascinating little detail about fine-tuning. It seems that even though it's not the best tool for this job, it's not a complete failure either. Turns out there's a secret to making it work. The key idea from the researchers was this: if you really want an LLM to learn something brand new through fine-tuning, you can't just show it the fact one time. You have to repeat it, you have to rephrase it, and you have to show it that same piece of information in a bunch of different ways. You know, kind of like how we humans learn. And they didn't just guess this, they proved it. Check out this chart. As they fed the model more and more paraphrased versions of each new fact from 0 all the way up to 10, the model's accuracy on questions about those facts just kept climbing. It's a really cool insight. Just showing it the fact once isn't enough. The model has to see it from different angles to really get it. So, what does this all mean? We know RAG is the king for injecting facts, but fine-tuning still has its place, especially for teaching a model a new skill, not just new knowledge. So how in the world do you pick the right strategy for your job? Well, a framework like this can really help. Just ask yourself a few questions. Does my data change all the time? Do I need to prove where every piece of information came from? If the answer is yes, RAG is almost certainly your best bet. But if your data is stable, you have a dedicated machine learning team, and raw speed is the most important thing for a repeatable task, like, say, classifying customer feedback, then fine-tuning starts to look like a really good option. Okay, let's boil this whole thing down to 3 main takeaways. Number 1, use RAG when you need real-time answers from data that's always changing. Number 2, use fine-tuning when you need to teach the model a new behavior for a structured task where every millisecond of speed counts. And number 3, probably the smartest move for most people, start with RAG. It gives you quick wins, then you can selectively fine-tune later for those few high-value tasks where it makes sense. And that leaves us with one last, kind of big question to think about. The massive success of RAG really makes you wonder, is the future of AI about building bigger and bigger models that know everything? Or is it actually about getting really, really good at retrieval, about building incredibly smart, super fast librarians that can find the perfect piece of information for the models we already have? It's something to chew on.